Today we'll take a look at the Commodore Universal Bench Power Supply in action, and I'll explain where I've been. So last time we took a look at the design, the parts, and the requirements for the Commodore Universal Bench Power Supply. Today what I want to do is take a look at it in action. My plan was that the next video would be a detailed build video, but unfortunately my wrist issues got worse. They got a lot worse. I got a cortisone shot, and it's helping, so things are going in the right direction. But as it is right now, the build video, which is 90% shot, is a beast, and it needs hours and hours and hours of editing. My wrist is really not up to it. So I thought I'd shoot this real quick, not do a lot of editing on it, and just show you that this does work, and that the build video is coming up. It's shot. I just didn't want to keep you guys waiting any longer because, you know, it's been about, what, a month? So yeah, this video is not as heavily edited as I usually do, but right now it's pretty much that or nothing. So when I use this, all I have to do, just turn it off, is for each computer I have a patch cable like this one. This is for the Commodore 64. I went ahead and got this one made. I will be including some additional patch cables in the build video. We'll run an Amiga and some other things on it, but I've tested the voltages, they're all good. For right now, let's try this on a Commodore 64. So what I do is I plug it into the front panel, and it just locks in with the Aviation Connector. And then the power connector will go straight to a Commodore 64, such as this one. And plug it in, the power supply on, and turn the Commodore on. And as you can see, the voltages, especially the 12 volt, tends to be a little bit low. The 5 volt tends to be a little bit high. Switching supplies without a load on them aren't quite as accurate, it seems. As soon as you turn it on, it locks right in at 12 volts. The 5 volt doesn't really vary much at all. As you can see, we changed the front panel to accommodate 2 voltage meters and the 2 aviation connectors. Of course, in the earlier video, I believe we had the 3 meter panel with 2 connectors. I found that the connector being in the center tend to flex a little too much, so we moved them lower, closer to the edge. They don't flex as badly. If we take a look at the back panel, all it has on it is the power inlet for a standard PC power cable, and on-off switch, and then there's a removable fuse here. Of course, I'm in the US, so this is all set up for 110 volts. I'll talk about this more in the build video. So if you're on a different voltage system, 220, you got to make sure that you're set up correctly for that voltage. The switching power supply I'm using, it doesn't care, but you got to make sure that your fuse is correct. You got to make sure that your transformer is correct. So I built this one using a 9 volt 3 amp AC power supply. That's sufficient to drive any Commodore that used a brick, including the early VIC-20s that used 9 volts AC at 3 amps exclusively. Now, if you don't need to run those early VICs, you can just use a 9 volt 1 amp AC wall wart, such as this one. And it's a little easier to wire up, and I'll show that in the build video. So the front panel here has 2 aviation connectors. The first one is this 4-pin one, which is exclusively used for an external floppy drive like this 1541-2. The other one here is an 8-pin, and this is for powering the computers. So this connector has on it 5 volts, 12 volts, and negative 12 volts DC, 9 volts AC, as well as the common and ground connections. There's also an unused pin that can be used for 9 volts DC for the Commodore 16 and the Commodore 116 if you choose to do that. I haven't done that in mine yet, but it's, you know, it's accommodated. I just need to get the right power brick and stick it in there, or a 9 volt DC wall wart is what I'd need. The 4-pin one should never be used for anything that's going to draw more than 1 amp of 5 volts or a half amp of 12 volts. You don't want to exceed that. For the other one, the 5 volts AC has 4 amps available. You can draw 5 amps if you don't connect anything on the other connector, the 4-pin connector. It has an amp of 12 volts. It has a half an amp of negative 12 volts. So that should be sufficient to run pretty much any Commodore that uses an external power brick. I had a person comment on Facebook that an Amiga 1200 that's heavily loaded with power-hungry mods might not run stably on a switching power supply. Looking at the specs of the 1200, this should work just fine. If you have an Amiga 1200 that's so loaded with mods that it's exceeding the requirements of the original power supply, then yeah, this may not provide enough power. Until I get a heavily laden 1200, I really can't test it. Once I have one, I'll test it on my bench and put the scope on the power and just make sure everything runs stably. If you are using a heavily modded 1200, you might want to not use the external floppy connector. That way you have 5 rather than 4 amps of 5 volts available. I believe the 1200's power supply specification is 4 amps, so an additional amp. I don't know what mods you guys are putting in these, so you never know. If I had a 1200, I would not be at all uncomfortable hooking it up and running it. All right, so as you can see, this Commodore 64 is happily running along. We'll load up and test it with a little bit of Moon Patrol. So there's a blog post on my website. That's at RavenWolfFarm.com. I've got a couple of blog posts already up. I have several more in the works, including one on making patch cables. The build video is, like I said, it's 90% shot. All I have left to shoot for that is the ending and building a patch cable. So we'll take a look at that. I'll get that out as soon as I can. I expect it to be in the next couple of weeks. I'll get it as quick as I can. Like I said, the wrist is doing better, but root canal on Wednesday, so we'll see how that goes.